Okay, for this question, it says the points A, B with coordinates 1, -9, -1, -9, 7, -5 lie on the circle with equation. We go equation of the circle. Find the equation of the perpendicular bisector of the line segment AB. So there are a few things we need to do here. And the first thing is to sketch a diagram, because that would really give you a good idea. So if I make that to be a circle, and in exams, you can quickly sketch a circle, and the points A, B with coordinates lie on the circle. So if we have, let's just imagine that's your X, your Y, and then -1, -9, that's your X and Y. So let's mark that point, say -1 there, and then -9, this point there. So that's A, -1, -9. And then the other one is 7, -5. Say 7 is there. -5, that's B. 7, -5. So the points A and B with coordinates lie on the circle with the equation. Find the equation of perpendicular bikes. So we want to draw the line AB. The line AB, I will use blue color for line AB. So use that line AB. We want to find equation of perpendicular bisector. What does bisector mean?
Like they both intersect, I think.
Bisector means you divide the line into two equal parts. So if I go see this green line, if I want to bisect it, I'll put it in the middle there. Does that make sense?
Yes, sir.
So what you want to do now is you want to bisect that blue line, a perpendicular bisector. Let me use a green line for that. Let's see if that will help. Something that would be, let me make AB to be exactly from A to exactly from B. You see the blue line there? We want to divide that blue line into two. Let's say you measure it, it was 10 centimeters. You want a perpendicular bisector, something that will divide it into two. See a perpendicular there, such that this side is say 90 degrees. This side is say 90 degrees. Does that make sense?
Yes, sir.
And it divides it into two. So now, so that means we're finding something in the middle. Let's write down the formulas that we need. Which formula do we need to find that middle, that midpoint? Do you know the midpoint formula?
Yes, sir.
Okay, tell me the formula.
The midpoint formula is just y2 minus y1 over 2, then x minus x1 over 2. Sorry, y2 minus y1. Sorry, y2
Think again.
plus y2 plus y1 over 2.
Not y2.
Then
Okay, let's start with the x coordinates. x1 plus
x2
over 2. Next one.
y1 plus y2 over 2.
Over 2. Okay, that's one of the formulas that we need for this question. What's another formula we need for this question? Let's just write out all the formula we need. What's the next formula we need?
The equation of the line.
Yes, tell me.
Y minus y1
Mm-hmm.
is equals to mx minus x1.
Perfect. Which other equation we need?
The gradient
Mm-hmm.
of the line.
Go ahead.
Y2 minus y1, x2 minus x1.
About those three. And
The
okay.
Okay,
with those three, those ones should be the things that we use for that question. So now on that question, the first line, we want to use that first equation. And when you put that first equation, you get that midpoint to be 3 minus 7. When you substitute x1, which is minus 1, x2, which is 7, y1, which is minus 9, and y2 is minus 5, it gives you 3, 7 for the midpoint. Fine, and then, so now that you know the midpoint, we want to find equation of the perpendicular bisector. So we find the gradient. You use that gradient formula, substitute y2 minus y1 is equals to x2 minus x1. That gives us the gradient of a half. So we know the gradient, and we know a point it passes through. So the gradient of the perpendicular to AB is minus a half. How do we change from this half to minus 2? Why do they change from half to minus 2?
Because they use the tangent formula.
Because if you have that circle, when you say tangent formula, I'm not sure which formula that is. You have that line A to be there.
Yes.
And then you have the perpendicular bisector in blue. So which one has a gradient of half? Which one has a gradient of minus 2? Look at the blue and the green line. The half is the gradient of which one? The green line or the blue line? Choose one of
the blue line.
The blue line, because that's the one you use the formula from A and B. So the half is for the half is the green line, sorry. The half is for the green line. Does that make sense? Because what you have done is you've used A, which is, you've used this A there, and you've used that B there to find that gradient of half. So that half is for the line segment AB, which is green in color. Now, in order to get the gradient for the blue line, because the green and the blue line meet at 90 degrees, because a perpendicular bisector, that's what perpendicular means. That means they meet at 90 degrees. So to get that, it will be minus 1 divided by 1 over 2. Does that make sense?
Yes, sir.
And then that will give you minus 2. So the gradient for the blue line now is minus 2. So now we know the gradient for the blue line. To find the gradient of the line itself now, we use that formula. I'll highlight the formula in yellow. Y minus y1 equals to m bracket x minus x1. And we know gradient is minus 2. So m is minus 2. x1 is the 3 that we work out there, the midpoint. And x2, y1 is the minus 7. That's the midpoint, because the blue line passes at that midpoint. Let me draw a line to meet that midpoint in orange. I'll point this arrow there. Can you see the arrow pointing the midpoint?
Yes, sir.
The midpoint of the green line, that's very important there to see it that way. So that point is the midpoint. And that's the 3, 7. Now we solve that into the equation. The rest is algebra. You get your equation in the form y equals to mx plus c. You can write it this way and leave it that way. So y equals to minus 2x plus minus 1. And it's minus because the line is going down. The gradient is minus 2 because the blue line is going down from left to right. When you're going down from left to right, the gradient is negative. That's why it's minus 2. The green line is going up from left to right. So the gradient is plus half. It's going up, but not very big gradient. That's how you do part 3A. And then, can you read part 3B for me, please?
So that the perpendicular of bisector AB passes through the center of the circle C.
Yes, so we need to know the center of the circle and the perpendicular bisector AB. Do we know the equation for the perpendicular bisector? Yes, that's what we
Yes.
just found out. So we would go now and show that it passes through the center. So the first thing to do is we have here center of the circle is 1 minus 3. And how do we get the 1 plus 1? I'll put a long line to show you how that plus 1 comes from. The plus 1 comes from this minus 1 there. And the minus 3 comes because it was a plus there. So when it is a plus, you change it to minus. And when it's a minus, it's a plus. So the center is 1 minus 3. So now in that equation, that blue line, we're soon running out of colors. The blue line there, the equation is minus 2x minus 1. So we sub in x to be 1. And what does it give us when we put x to be 1? Minus 2 times 1 minus 1, it gives you minus 3, which is the equation for the center. So you conclude, therefore, sometimes I put therefore with 3 dots like that if I don't want to write it fully. Therefore, the perpendicular bisector of AB. Perpendicular bisector is the blue line. Perpendicular because it's at 90 degrees. Bisector, it divides it into 2 equal half. It divides the green into 2 parts. Passes through the center of the circle. Because when you substitute 1, you get minus 3. So that line passes through the center of the circle. And that's the conclusion for that one. So that's how you do that question. And it requires putting all those formulas together and taking your time and applying them without making mistakes.